How comes we're losing vegetation, and how does that lead to topsoil loss? So maybe we can start out by looking at how much topsoil is lost globally. According to Lee and his research group, in an overview of soil loss tolerance, that's the name of the article, and I will put the link to this article in the description. He says, in very favorable conditions, such as good cover of trees, grass, and other protective vegetations, the rate of topsoil formation amounts to 0.025 to 0.085 millimeters a year. And here he cites an article by Bennett, written in 1939. However, erosion under anthropic conditions might reach 2 millimeters a year, which significantly exceeds the rates of topsoil formation and natural erosion. So why is topsoil important? Topsoil is crucial in regards to climate change because large amounts of carbon are stored within it. There's biomass within it, meaning the mass formed by living creatures inside the topsoil, and necromass, the mass consisting of that plant matter. This decomposing necromass is what provides nutrients for plants to grow, nutrients that allow our crops, among other plants, to grow. The topsoil has a porous structure. These pores can absorb and store humidity, keeping water available for plants to thrive. If we lose topsoil, we lose stored carbon that can be emitted into the atmosphere as greenhouse gases and the nutrients feeding the plants that feed us humans and our livestock. Grazing animals such as cows, goats, and sheep can have a negative impact on vegetation cover, especially when they consume grass and shrubs faster than it can regenerate. Still hungry, these animals will bite down on every last bit of foliage and grass they can find. We refer to this phenomenon as overgrazing. Loss of vegetation cover can be a strong driver of erosion and subsequent desertification. However, animals are not the only thing that is exposing bare soil to wind and water. Many of the crops we grow and the manner in which we grow them require fields to be plowed. The soil is moved every year, and the single crop that we grow, grows quick because of a lack of other plants absorbing its nutrients from the soil. While being very beneficial for the farmer on the short term, as it allows his crop to grow undisturbed from other vegetation, this practice exposes topsoil to erosion with almost no root structures holding it in place anymore. This loss of soil can be damaging to farmers on the long run. However, we are here to talk about architecture and construction. Do they play a role in this too? Yes, they do. Whenever a plot of land is cleared for the construction of a house, the topsoil needs to be removed. It is common practice to store this soil on site in a big heap or even to landfill it. I don't think we even need to mention why landfilling topsoil is bad. But let's talk a moment about the heaps. If stored in heaps, the quality of the soil degrades, as described by Karim in Effects on Topsoil of Long-Term Storage in Stockpiles. And he says, a study of stockpiles of different size, age, and soil type has revealed that biological, chemical, and physical changes do occur, mainly as a result of anaerobic conditions within the heaps, but also as a result of mechanized handling during the stripping and stockpiling. Visible changes occur between 30 centimeters of the surface of stockpiles of clay textured softs, but only below about 2 meters of depth for sandy textures. These visible changes are accompanied by chemical changes, particularly in the forms of nitrogen present also in the content of available nutrients, pH, and organic matter levels. Biological changes include reductions in potential for epithelial infection, soil biomass, and especially earthworm population. Considering that soil is also a commercially available product, wouldn't it make more sense, now that we have this knowledge, to back it up, ship it to other construction sites that are currently in the landscaping phase, and when the time has passed, the construction has reached a point that also on this building, this construction site on this building, you can start landscaping, that then you make topsoil arrive from other construction sites. Maybe that would be a more reasonable approach, at least on a biological level. Could we maybe encourage that through policies in the future? Water and wind erode our topsoil quicker in absence of vegetation and root structures protecting it. Raindrops that didn't get slowed down by foliage strike the ground, dislodging soil particles. These particles are then transported by surface runoff as water gathers and flows downhill. The faster it flows, the more it is able to hold on to those particles. The slower it flows, the more likely it is to give those particles back to the soil. With no roots and grasses to slow it down, the water gains speed. It can create small channels called rills. Rills deepen into gullies, carving out larger pathways in the landscape. Over time, these gullies can expand and deepen, leading to significant landscape changes. Wind erosion occurs when strong winds blow across bare and loosely covered soil surfaces. The absence of root structures means the ground is not held together, and the absence of vegetation above ground allows the wind to reach the ground itself. These winds lift lightweight soil particles into the air, creating a suspended cloud of dust and sand. As no foliage is present that can catch these particles again, they are carried by the wind and can be transported over long distances before settling back to the ground. They can impact human comfort even in cities that are hundreds of kilometers away, as is regularly happening in China. Since we talked about grazing animals, we need to talk about a controversy too. Herding is often done by vulnerable communities, and their livelihood depends on it. So fencing off big areas could obviously be a solution to prevent further vegetation loss. But at the same time, it's important to keep in mind what effects such measures have on such vulnerable communities. When vegetation cover is lost and there are no structures in place that are able to retain water in the landscape during major downpours, these can quickly lead to landslides or to floods downstream. What are dry pits? One approach not only to conserve soil but also to catch the eroding topsoil and even to restore new soil and vegetation cover are dry pits. These are rows of half-moon-shaped holes. They're dug in the ground and the opening of the hole faces upslope. And the rows are placed so that overflow from one pit is directed into the next row downslope. The deepest point in which water and sediment is concentrated can then be planted. Another approach, usually done with bigger construction equipment, is terracing. As soil erodes more quickly on steep slopes and the sediment is deposited in those places where water slows down, terraces allow to catch sediment and once replanted conserve soil. A strategy to reduce wind speeds and allow for greater agricultural productivity are windbreaks. These are long rows of tall trees along the edges of fields planted perpendicular to the prevailing wind direction. They allow plants vulnerable to such strong winds to be grown within the areas they protect. Another mitigation strategy in areas affected by wind erosion are straw checkerboards. Vertical rows of straw stalks are placed vertically into the ground, intersecting lines, thereby forming a checkerboard. This structure is able to reduce wind speeds at ground level so much that on top of stopping erosion, it can even catch sediment